Welcome to geometry class. Sorry I'm not here today. This is Mr. Nansky. You get to listen to me for the next class period. We're going to talk today about writing equations of parallel and perpendicular lines. At this point, you should have collected, turned in your homework. Into the substitute teacher. Before I forget, there is a quiz next class. That means on Tuesday, you will have a quiz on Module 4. We'll do a review for the first part of class and take the quiz in the second part. So you've already talked about, you should have talked about your independent practice in your groups. Answer any questions there. Let me start out by talking about slopes. Recall that the slope of a straight line in the coordinate plane is the ratio of rise over run. In this figure, I'm going to look at the line AB, which you can see is the blue line that you see on your paper. I do not like the triangle they put because they did run first. If we do rise, we go up. We're going to go up 1, 2, 3, 4 units, right? From there, I'm going to the right. 1, 2, 3, 4, 5, 6, 7, 8. So my rise over run is 4 over 8. We want to simplify all fractions. If I simplify 4/8, 4/8 is the same as 1/2. I can divide the top and bottom both by 4. Gives me 1/2, so my slope is 1/2. So we find slope. The next thing we're going to look at here are equations. We're going to talk about equations in slope-intercept form. The reason we call it slope-intercept form is because from the equation, I can easily look at the equation and tell and determine what the slope is and what the y-intercept. We have two forms that we use a lot. The first form is the form that your book actually uses. Y equals mx plus b. You see right here that I've underlined it. In this equation, m is representing the slope, and b represents the y-intercept. That's your traditional slope-intercept equation. The other one is an equation which is used a little bit more often. It's kind of a little bit different. Is we use y equals a plus bx. Well, over here we represent a represents our start, is how we call it, which in reality our start is just our y-intercept. Our b in this particular equation refers to the rate of change, which the rate of change is just the slope. Whichever equation you use doesn't really matter. Just note that the number that is in front of the variable x is our slope, or rate of change. The number that's by itself is our y-intercept, or the start, the value that we start at. So what I want you to do is right now, on your own here quickly, go ahead and graph. Exploring the slopes of lines. Part A, graph the equations. Y equals 2 times the quantity, 2x plus 1, and the line y equals 2x minus 3. Go ahead and graph both of those. So you'll see I've graphed them as well up there. The blue line that you see is our first equation, and the green line is my second equation, y equals 2x minus 3. The question is, what do you notice about the graphs of these two lines? They appear to be parallel, don't they? Yeah. Well, how do I know if they're parallel? What do I notice about the slopes of the two lines? So when I graphed them up above, the first equation had a slope of 2 and a y-intercept of 2. The second equation had a slope of 2 and a y-intercept of negative 3. Well, they both, what do I know about the slopes of both lines? They both have a slope of 2. Which leads us to our statement here when talking about parallel lines. If two non-vertical lines are parallel, then they will have equal slopes. Parallel lines have the same slope. Parallel lines have the same slope. Now, we're going to take a look at the line y equals negative 3x plus 5. I want you right now to go ahead and graph it. It's got a y-intercept of 5, a slope of negative 3, graph the line. There's 5, slope of negative 3 means it goes down 3 over 1. I just keep going over. It helps me to get my line straighter. If I'm drawing a line through multiple points, it'll be straighter than just doing 2. So there I've got my line. What I want to look at is, what do you notice about the point 1, 2? 1, 2. Here it is. I have made that point in blue. Right there it is. What do I notice about it? It happens to be on the line. It appears to be on my line. So does the point appear to be on my line? Yes, it does. So recall that the point 1, 2. 1 is the x value of that point. 2 is the y value of that point. And that can be substituted into the equation for the line. So what we're going to do is we're going to take the point 1, 2, and we're going to substitute it into my equation. 1 for x. Note my equation was y equals negative 3x plus 5. I am replacing x with 1, replacing y with 2. And what I'm going to do is simplify the right side. Negative 3 times 1 is negative 3. Negative 3 plus 5 is 2. Well, the left side already equaled 2. So what do you know what happens? Well, 2 equals 2. When I simplify it, both sides are equal in this equation. Which, if a point is on a line, it will simplify to be equal. If the point is not on the line, it won't work out that way. You'll get a different number on the right side and a different number on the left side. That is important to us because we're going to look at this here as we go on to the next page. Because we're going to now look at talking about parallel lines and write an equation. So we want to write the equation of the line in slope-intercept form. It has to be parallel to y equals 5x plus 1 and pass through the point negative 1, 2. Well, before I write this equation, if I look at GeoGebra here, I have already pre-graphed both of these lines. The blue line you see here is the equation y equals 5x plus 1. You will notice the point negative 1, 2 is also graphed here. Okay, and it's labeled there. And I used the GeoGebra feature to draw a parallel line through that point parallel to the other one. And it also gave me the equation. Gave me the equation y equals 5x plus 7. So the orange line is parallel to the blue line and goes to the point negative 1, 2. So my answer is going to be 5x plus 7. What we're going to look at is how can I get that answer algebraically. We've got it graphically using the computer software. Well, what do we know? If we go back to our slides here, parallel lines have the same slope. My original line right here has a slope of 5, which means my new line will have to have a slope that is equal to that, which means my new line is a slope of 5. The y-intercept's not going to be the same. The y-intercept's going to change. I don't know the y-intercept of my new line. But what I do know is it passes through the point what? -1, 2. So my new line has a slope of 5, 1 and go through the points -1, 2. So we're going to go back to kind of what we talked about. So we'll start with our equation. Y equals mx plus b. What I know is that my slope is 5. So I'm going to replace m with 5. I do not know the y-intercept, so I leave that as b. I'm going to try to find it. Well, in order to find that, what I do know is that it has to go through the point -1, 2. Remember in the previous slide, we said that if a point was on the line, it had to satisfy the equation. Well, what I'm going to do is plug that point in for x and y. -1 for x, 2 for y. What I'm going to do is find a value of y that's going to make the left side of the equation equal the right side. 5 times -1 is -5 plus b. To solve for b, I'm going to add 5 to both sides. 2 plus 5 is 7. So b is 7. That means my y-intercept of my new equation is 7. Therefore, using my equation, y equals what? So I get y equals 5x plus b. Now that I know 7, now that I know that b is 7, I can get rid of the b and give my answer as y equals 5x plus 7, which, quickly popping back to GeoGebra, that's what we said the answer was going to be graphically. Let's look at another one here together. So I want to write the equation of the line in slope-intercept form. Parallel to y equals -3x plus 4, and go through the point 9, -6. Remember, parallel lines have the same slope. My original line here, remember the slope's the number in front of x, has a slope of not -3x, but of -3. So therefore, my new line that I'm going to write the equation of will also have a slope of what? -3. Y equals mx plus b. I know my slope is -3, so I'm going to replace m with that -3. But I don't know my y-intercept or b yet, but I do know it has to go through the point. So I'm going to plug in the point 9, -6, in for x and y. 9 for x, -6 for y. And I want to solve this equation for b. -3 times 9 is -27. -6 equals -27 plus b. I'm going to add 27 to both sides. You get 21 equals b. There's my y-intercept. So what's my equation going to look like? Y equals -3x plus 21. As we reflect, question number 3 here says, what's the equation of the line given through a point and parallel to the x-axis. If I draw the x-axis here, and there's the y-axis, remember it has to be parallel to the x-axis. Means it's going to be a horizontal line. What can you tell me about the slope of a horizontal line? It's 0. The slope of this line is 0, which means if I write my equation, I get y equals 0 times x plus b. Well, 0 times any number is what? 0. So this is going to cancel out. What am I left with? Y equals b. So if I ever have a line that is parallel to the y-axis, a horizontal line, it is always going to be in the form of, the equation is going to be in the form of y equals b. So right now, it's your turn. I want you to pause the video, and you guys are going to take 5 minutes here to write the equation for number 4 and number 5. After you have completed that, the answers will then appear once you replay the video. So go ahead, hit pause. And here are the answers to both of those. If you need these to stay for a little bit longer, for people to check, you can pause the video at this time for that. But there's the answers to number 4 and number 5. Next, we're going to look at two lines here that intersect. In the graph to the right, write the equation of each line. Identify the slope and the y-intercept of both of them. The first line, A here, which starts up here. If I look at it, I got 1, 2, 3, 4, 5. You'll notice the y-intercept is 6. And the slope, from there it goes down 1, 2, 3, and to the right 2. So there's a slope of 3 over 2. And since it's going down, it will have a slope of negative 3 over 2. So it's negative 3x plus 6, which is the y-intercept. If I look at line B, which starts down the bottom left and works our way up, this one is a y-intercept of negative 4. Well, to find the slope, if I start at the y-intercept, it goes up 2 units, and this one goes to the right 3. So my equation is y equals 2/3 x plus a negative 4, or minus 4. If you look at these two lines, what do you notice about the angle formed between them? If I get out my protractor here and line it up, what you will notice is that this angle is what? It's 90 degrees. It is a right angle. And what do I know about two lines that form a right angle? The lines are perpendicular. So what I want to look at is what do I notice about the relationship between these slopes. The first slope being negative 3/2 for line A. The second one being a positive 2/3. What do I know about those two slopes? One's positive, one's negative. What else do I notice? I flipped them, right? So what I noticed here is I changed the sign. and I flipped the fractions. What we do is we call that opposite reciprocal slopes. So therefore, the slopes of perpendicular lines have opposite reciprocal slopes. Remember, opposite means to change the sign from positive to negative or negative to positive. Reciprocal means to flip the fraction. 3 over 2 became 2 over 3. So we'll go ahead and take a look at 2 of these here together. When I write my equation of perpendicular lines, it's very similar, but what we do have to note is the slopes are different. So if I want to write the equation of the line, for example, 2 letter A, the line perpendicular to y equals 4x minus 2, and go through the point 3, negative 1. My line right here has a slope of 4. But remember, parallel lines have the same slope, but perpendicular lines, their slopes are the opposite reciprocal. So this line will have so since it's positive, will become negative. 4 is the same as 4 over 1. So when I flip that fraction, I get 1 over 4, negative 1/4. That is the key with writing perpendicular lines. You have to flip, have to get the correct slope. It's the opposite reciprocal. So when I write the equation of my new line has to have a slope of negative 1/4, and it must go through the point 3, negative 1. Now that I've identified that, I'm writing it the same way I did before. Y equals mx plus b. I can plug in my slope, which is negative 1/4. I don't know the y-intercept, but I can find it, remember, by plugging in what? 3 for x, negative 1 for y, because the point has to, if the point's on the line, it has to satisfy the equation so that both sides are equal. I just need to find the value of b that will do that. Negative 1 equals negative 1/4 times 3 is negative 3/4 plus b. I'm going to add 3/4 to both sides. If I add 3/4 to negative 1, I end up with negative 1/4 is b. There's my y-intercept. Now that I know what b is, I can take my equation. Y equals negative 1/4 x plus, what's the y-intercept? Plus the negative 1/4 or minus 1/4. Coincidence that the slope and y-intercept are the same answer. Example number 2, letter B. The line perpendicular to y equals negative 2/5 x plus 12 and pass through the point negative 6 to negative 8. So this line has a slope of negative 2/5. Remember, perpendicular lines, their slopes are opposite reciprocals. So my new line has to have a slope opposite. So it was negative, will become positive. The reciprocal means I'm going to flip 2/5. the numerator becomes the denominator becomes the numerator. So if I flip 2 over 5, it becomes 5 over 2. So my slope is 5 over 2, and I want my equation to go through the point -6, -8. Y equals mx plus b. I know my slope is 5 over 2, so I'm going to replace m with 5 over 2. But I don't know b. Well, I'm going to find it by plugging in what? My point for x and y. Y is -8. 5 halves times -6 plus b. -5 halves times -6 gives me -15 plus b. Add 15 to both sides. I end up with b equals 7. That means the y-intercept is 7. Well, now that I know the y-intercept, I have my equation. Y equals 5 halves x plus 7 is my equation. Reflect question number 6. As your friend says that if two lines of opposite slopes, they're perpendicular. He uses 1 and -1 as examples. Do you agree with your friend? Take a minute, discuss with the person next to you. Well, in this case, 1 and -1, if I write them as fractions, it's 1 over 1 and -1 over 1. They are opposite reciprocals, aren't they? But he just said opposite slopes. What if I gave you the example of 2 and -2? Are 2 and -2 opposite reciprocals? No. So do you agree? No, because they have to be opposite reciprocals. So right now, I want you to pause the video, and I want you on your own, take 5 minutes here to write the equation of the lines in slope-intercept form that are perpendicular to the given lines, numbers 7 and 8. You're doing your turn, numbers 7 and 8. So now you've got the answers here. Y equals -2/3 x plus 1 is the first one, and y equals 1/4 x is the equation of the second one. What you will notice in number 8, the y-intercept is 0. If the y-intercept is 0, I do not need to write it. I can just write it as, forget it, instead of writing plus 0, I don't need to add it. What I want you to do right now is pause the video, and I want you to take a couple minutes to discuss questions 9, 10, and 11. And then we will discuss them here in a little bit. But I want you to discuss questions 9, 10, and 11 right now in your group, so pause the video. Okay, welcome back. So eyes up here, focus, discussion. Question number 9. Would it make sense to find the equation of a line that is parallel to a given line T and goes through a point on that given line T? So here's my line T. Remember, if it's parallel, it's got the same slope. And it has to go through a point that's on T. What can you tell me about that line? Would it make sense? No. Why not? Because if it's got the same slope, it's going to end up being the same line. It has to go up. Well, I drew it off a little bit here so you can see the difference, but they're really what? The same line. Question number 10, would it make sense to find the equation of a line perpendicular to a line K? So my blue line is line K, and goes through a point on point K. So it's got to be perpendicular to that. Could I? Yeah. Would that make sense? Yes, it would. And what would you know about point? The point? Yes. They would just intersect at that given point. And lastly, the essential question of today, how are the slopes of parallel lines and perpendicular lines related? Parallel lines, their slopes have what? The same slope. Perpendicular lines, their slopes are opposite reciprocals of each other. Your homework can be found from 4.5. Remember, we do have a quiz next class on Module 4. You have the rest of the class time to work on your homework. Thank you.